So this session is named Business Central Online Handle Large Customers. You would of course be very surprised if I said probably guessing the answer already. But what I'm going to talk about here, first of all, my name is Jan Peters. I run the server team of Business Central. So this is what I do, making sure this happens. That's probably the most important for my team. So what I'm going to talk about today is first just a little introduction to how the service has evolved. And then I'm going to talk about how Business Central actually scales online, what we're doing to make it into a good service. And we're also going to talk about how large is a big customer. I'm going to do that by presenting data from our service about the size of customers we already are running. That can give you an idea of whether what you're thinking is or it's just a normal game. And then I'm also going to introduce the new limits for web service calls that you might have seen, which also plays into this larger customers and their needs. And so this session is about the second bullet point you saw in Michael Morton's presentation, the world-class service part. It's a slightly odd session at this conference because the mentioning of Copilot in a minute will be very low. I will not be talking about AI. I'll just be talking about what we do to give customers the best possible service when running Business Central online. So, history. In April 2016, we launched a project called Project Clara. There was a bit of confusion. Was this a new product? What was it? It was targeting a very low end market. I guess it's a public secret that it was just dynamic now. Just limited to less functionality and shipped as a service. And to be honest, it was not really a great fit for the market because all of you partners, you were used to selling Dynamics Nav, you were used to that functionality. Suddenly going down market, etc., was not a great success, but it told us a lot of things. And then in April 2018, it got renamed to what it actually was, Dynamics 365 Business Central Online, and all the limitations basically were removed, so now you would have the same offering in the cloud as you would have on premises. Now, even though we learned from Project Madeira, there are a number of things we didn't do that well back then. We didn't have automatic load balancing between VMs. We didn't have auto scaling of capacity and database graphs. I'll get back to what that means. And fortunately, we have a number of smart partners, and in the beginning, they were smart enough to sign up their smaller customers. So they learned while we learned. Now, it was actually quite a success. The growth rates we have seen since 2018 has been astounding. Really happy with that, and we're continuing to see growth. So even though it was what you call an immature service, it was definitely good enough that we were able to grow, that we were able to attract new customers, etc. Now, what I'm going to talk about today is the current state, where at least I consider it our service to be a mature service, and we can see larger and larger customers choosing to go to the cloud. So what does it mean when I say that larger and larger customers go to cloud? What does it mean that customers get larger? Well, they can get more users instead of just having a single user system. That was probably the target of Project Madeira. You can have a lot more users. And what happens then? Does it still scale? And then what about more integrations with other systems? Does it scale with more APIs? want to hear about how you can write more performant code, we have other sessions for that. We're lucky enough to have a session tomorrow about locking and what's new in server database. This session is about what we do to handle the larger customers, the larger demands on, say, the service itself. Now, larger customers usually also have more data. And in other things, the amount of sales orders you need to close per day, the amount of job queue jobs you need to run, etc. So let's dive into how Business Central Online scales, so that you get a feeling for what's going on behind the scenes. Now, of course, there are some potential bottlenecks when you run. Now, this is a very simplistic picture. Basically saying that users and API calls connect to the server, the web server, and the server tier. And then there's a database behind that. And first, gonna look at the compute tier, what we call the compute tier, which is effectively the NST. Now, actually, we have some people asking, why is it called the NST? That's odd. Well, we're a traditional company. It used to be called Navision and Nav, and then the service tier. So that's actually the NST part. And it sneaks into our presentation still because some habits just linger on. So, how do we handle heavy load on the compute tier? Now, I'm going to base this example on a measure of CPU. That's only one measure of heavy load. It can also be memory consumption, it can be thread consumption, etc. But it's just easier to relate to one measure. So that's why this presentation mainly focuses on that. But do rest assured, we're also measuring other things and load balancing based on that. Now, what happens when we get a lot of requests coming in? Well, usually you might be served by one VM, but actually behind the scenes there are a number of VMs. Now, if we start, and then there's a load balancer in front of it. So, in general, we do not abandon sessions. The way we do load balancing is that new requests go to different nodes if they're overloaded. Now, with API calls, that happens a lot. So it's not really a big limitation that we don't transfer sessions from one machine to another. So for instance, in this case, when things are running smoothly, all the CPUs are humming along quite nicely, then suddenly one of them spikes up to above a certain threshold. These thresholds we adjust all the time to find out what's the best trade-off between moving people around versus being served on a given VM. So in this case, we'll actually flag that this session should not receive any new session until it's below the threshold again. And then automatically the request goes to other VMs. So let's take an example of, and this is actually true data, it's just a graphical representation of a cluster in the US in the evening, April 10th. We had 9 VMs running there. And this was a graph of the VM load. And then 2 VMs actually start doing a lot of work. We don't know what they're doing, but to be honest, it doesn't matter. The pattern continues. And now there's another VM that starts picking up. And now we're getting close to the time where this is starting to be problematic. There are some of these that are close to being what we call starved. So in this case, what you'll see here is that at the midpoint at 5:39, we actually start spinning up, or we start directing sessions to other nodes. So you now see the load moving over to a new node, and then that one gets lower. Now, if the load continues, that one will get higher up. So the sessions will get directed spikes and it goes away, and to be honest, no users feel it. So it's usually about a minute before the load balancer kicks in. But of course, you can also get into the situation where now a lot of nodes are overloaded. So this is an example from Sweden, where we had a cluster with 24 virtual machines. We run usually in clusters between 5 to 50 machines, so we have a separation. You don't need to care about what cluster you're working on, because you just have one endpoint, and then your tenant is being served by this cluster together with other tenants, etc. And we can move you around. You don't really feel that. So that's actually another way that we do the load balancing, is if historically these tenants have been very heavy, then they will actually get distributed so that what we think is an average distribution happens. Now, you can never know what the customer's going to do next. They might start heavy jobs in a minute, so we need to be able to react to that. So let's take a look at this cluster in Sweden. And locally, it was around 9 a.m. We're about 40% load. At about 9, it seems that the Swedes start working after they've had their morning coffee. Then they start doing some work. Coffee ended at 8:08, and at 8:09, they are more busy. It's actually funny how sometimes, and this is actually real data. So it might be that some actually have jobs set up to run, etc., to start the day off. And you can see that by now, all the VMs are relatively busy. And what we do here is it's a little longer than the other balancing, that if we've had a sustained high load for a couple of minutes, say, well, I guess it's time to add some capacity here. So actually at 8:12, you realize that we've had more than 3 minutes where we have had sufficiently high load, and as you can see, that's a pretty low threshold. We actually have quite a bit of room left, but we prefer to over-provision. So we don't need everything to be stored. No, it's actually when the average load on the cluster is, I think currently we're running 60%, but that varies day by day. So in this case, at 12 minutes past 8, we said, well, we need more. And a little later, now this takes a little longer. It takes about 10 minutes for us to add them, get them registered, get tenants transferred, etc. So at about 8:23, we start now distributing the tenants differently. Now you have more machines, meaning that the load goes down for all the tenants being served on this cluster, because we've added capacity to it. So this happens completely automatic. There's no human intervention. It's just monitoring, spinning up new nodes, etc. So how do we measure how we're doing? And we have an internal measure of, this becomes a little long to say, but basically how many UI session minutes are being served by VMs that have enough capacity. Basically VMs that do not exceed any threshold that we have set up. And our goal is that 99.95 UI session minutes should be served by VMs that have plenty of capacity. If we look back at Direction2022, we were at 99.66. Currently we're at 99.87. And we hopefully will get to our goal very soon. It's definitely attainable because we have the system in place. And if we put this into perspective, if you're working 4 hours in BC every working day, 5 days a week, and well, I said 0.13% of this time, an average user may have experienced slowness, because it's not certain that you have experienced slowness, but we did see some load on the system. Well, at 13%, that's 1 minute and 34 seconds over a work week. If you compare that, and our goal is 99.95%, would correspond to 36 seconds every week where you were impacted by lack of capacity. potential bottleneck, which is the database tier. Because you need to have enough CPU, data I/O, etc. We're using CPU, data I/O, upright, work percentage, session percentage, etc. on the databases, and we consider it to be overloaded if any of these are high. And again, we do the same where we distribute the databases in pools so that each pool is expected to have the same load. But then we also react if the load is too high. So for instance, if the CPU goes to 90%, then it's considered to be overloaded. Then we add more capacity to the database, or we move the database to a higher database tier. Now again, this in general does not have any effect on the customer. We can add CPU and other things to the database on the fly. Now there are a few operations that will give a small blip where the connection gets dropped and reconnected. For instance, if it needs to be moved from one data center to another, because there is also the automated failover. If there is something wrong in this data center, a failover will happen to another data center. For those, you will see a tiny, basically millisecond, in the order of magnitude of milliseconds, where existing connections end up getting dropped and new connections will get created. And of course, sometimes we can either scale up, and this is just an example of it happening in action. Again, if we want to see enough sustained load. So yes, we might be overburdened for some minutes before we actually scale up, because spikes are bound to happen. So it scales up, and then it takes about, in this case, after this it got scaled up there. You cannot see really when it finished because there was no real work on this database until 5 minutes later where it had been scaled up. But it actually happens within, I would say, seconds and minutes. And if we look at just the amount of databases, then this is a very stupid graph. Because if we look at how many, if we take the ones that have less than 1% usage, put them in, we can't really see these. Because I think it's about 0.2% that run over 1% of the capacity. So it doesn't really make a nice graph, right? But of course it can happen, and it can happen to your customers. And you should know, you will always hear about the cases where there is a performance problem. You don't hear about all the other ones where it doesn't happen. I know that very well, because we basically hear about every performance problem. And well, we have thousands and thousands of customers out there. And the good thing is, for the vast majority, we never hear from them, because things are running as they should. So, to summarize this part, the Business Central Online is designed to scale. We spread the load across multiple VMs. You might think, so what does it mean for the customers that it's spread over multiple VMs? The only place where you might see it is there is a cache synchronization happening across those, which happens within about 5 seconds. So there is the possibility that if you're not inside a write transaction, you can read cache data where somebody else has made changes within the last 1 second. But to be honest, it's not something that anybody is really concerned about. We don't really have any cases with that. So for the user, it's just nice. They get served by the node that has capacity. We add more VMs when needed, and also It just works. And you shouldn't really worry about whether there is enough database capacity or media capacity. So this is how, just a little insight into how we scale. It's actually quite a significant part of the organization that is working on making sure that this works all the time, which is not something you can really see in presentation. It's not new functionality. It's all of this infrastructure that runs behind it. So let's get to something that is maybe a little more tangible for you. Let's talk about what is a large customer in Business Central Online today. I'm going to present some numbers, and they are examples of customers, not what we have measured to be the limit, but these are numbers from customers that have seen this load, etc., that are running well. Now, we actually did a presentation in 2022. It's only here for comparison, and then we'll draw a few comparisons along the way. So if we look at number of records in various tables, back then, I think our biggest customer had about 1,000 users, 1.4 million sales invoice headers, and 7.6 million item ledger entry tables. Again, I don't know which customer it is. It's not the same customer, but these are actually data, but these are 2 years old. And back then, 5,400 sales orders was our busiest customer. Biggest sales order when we did that back then was 58,000 lines. And we had 160 gigabyte. We migrated from on-prem, data sizes up to 400 gigabytes, 312,000 interactive operations in one day. And as you can see, the web service call, 6 million in one day. The record back then was 140 calls per second for a customer. Now, of course, whenever I say this, a web service call is not just a web service call, because there are heavy web service calls and there are small web service calls. But we cannot go in and see what each web service call does, so we're just looking at the averages here. Now, as preparation for some of these presentations, we asked in our Yammer community, so what are your concerns about scalability? We got some replies. Very frequently we get them from the MVPs who are kind enough to answer when we ask questions. By the way, if whenever you have it, give us feedback about your concerns about scalability, etc. And so one of them was, well, is it a problem to have 120 people entering sales orders at the same time? Well, there are some customers that we have out there today that are creating a lot of sales orders. They might do it manually, or actually the ones that generally have the most are the ones who do it automatically, where it is synchronized with a web shop, Shopify, something else. Now, we had a lot of customers that create thousands of sales orders per hour. So that is not uncommon. Can be done. Now, of course, mileage will vary. If you add some business logic in events that requires a lot of things, then your mileage may differ. But this is not uncommon. We have many customers creating thousands of sales orders. So, one example we had from April was a customer creating 8,000 sales orders in 1 hour with about 60,000 lines in total. Another one created only half that, but with more lines, etc. So, we have evidence that the system handles this. So, and what about posting invoices, etc.? This is one of the places where we can actually compare a little. Yeah, you remember from 2 years ago, if you remember the other slide, back then we had 5,400 being one of the busiest customers we had. Today, we have many customers that post thousands of sales invoices per hour. So, one example we just looked up here, customer posting 5,000 invoices in 1 hour, 2,500. And remember, the other one was in 1 day. This is These are the observed numbers. We actually don't have any customers out there doing thousands of purchase orders in an hour. We see hundreds. Now, it might also mean that we haven't optimized this quite as well as the sales order process yet, because we use these measures also to determine where should we optimize our application. We should, of course, optimize it where it makes the most sense. So maybe purchase orders is next when that picks up. But right now, it is adequate. So it actually works. Number of users, you saw before, the maximum was 1,000. That's still in the high end. Now we have several customers above 1,000 users, and we have thousands of environments out there with more than 100 users. 100 users is nothing. That's average day. Don't worry about that. Now, we still have a lot of environments with less than 20 users, but don't be afraid if you're thinking about signing someone up with 100, 200, 400 users. Another measure of size of how large a customer is database size. Again, from 2 years ago, we talked about 400 gigabytes and 160 gigabytes migrated from on-premise. Still, most databases are below 100 gigabytes, but we have a lot of them, over 100 gigabytes. And I think currently the largest one is in the ballpark of 1.2 terabytes. Now, there's also a cost to size, so that might limit it. Last I checked, you get 80 gigabytes included, plus 1 to 3 gigabytes per user. So if you have a lot of users, you might actually have a lot of that for free. And then you can buy more. You can look up the add-on prices, the website. But this is something we're looking at. Do we actually need, what do we need to charge for database sizes? Because generally, it's not really a problem for us to handle large database sizes, at least not when we're not talking multiple terabytes. It works quite well. But of course, the more data you have, the more you'll be hurt by poor code. If you do iterative operations over millions or billions of records, it is bound to be slow. So this is where it's not really about hardware, that we can provision enough capacity for you. It's about the code which is in there. Now, many of the large databases come from on-premise. I hope you're aware of the cloud migration story, where it will move data into the cloud. And I think last month we can't remember whether these are March or April numbers. So it's common for us to migrate more than 100 gigabytes. We have a few over 250 gigabytes. And actually, we had a case with one of our dear partners that needed to upload this database of about 800 gigabytes. It took too long for them because the customer didn't really want to wait. It needed to complete overnight. So we invested in the performance of the cloud migration. And actually, we just hear about 4 weeks ago, we shipped a performance improvement to the cloud migration, which makes it about 5 to 6 times faster, allowing this customer to actually get their 800 gigabyte database into the cloud overnight. So it can be done. Now, when you have this amount of data, I would actually recommend it's a bit like when you move houses, right? Maybe you should throw out some of the old stuff instead of packing it all into containers and shipping it to your new house. It might be a good opportunity to think about, do I really need all of it? But in general, we can actually handle it. So that's another measure of database size. Browser interaction is basically anything you can do in a browser. This is mainly related to interacting users and what they do. It includes tabbing out of the field so that you save it, clicking a button, saving it out of the field, etc. This is actually one of the measures that we look at a lot. The which actually now we have a new record, 415,000. And well, we have some doing about 16 per second on average. Again, just because you can does not necessarily mean you should. If you run your jobs very frequently and they take logs, and all the other users are suffering because you're running this blocking operation all the time. So, but it's just to tell you it can actually scale quite well. And the last one I'm going to mention was switch calls, 10 million in one day. Now I have a small story about that. We actually did a performance optimization that helped quite a bit. Now, unfortunately, what we saw was that for a number of tenants, it just meant that they now multiplied the number of calls they did by that exact number, because they were just, the moment they got a response, they would call it back. So the faster we make it, the more calls they'll make. And it might be one of those that actually hit the 10 million mark, in which, and for 540 per second on average. Very busy tenant. Now you might say, so is Business Central online faster than on premises? Notice how I make this a positive question rather than the opposite. Again, it depends. What you can know is that it's Microsoft's responsibility to ensure enough capacity. Now, we cannot write your AL code. If your AL code does 1 million calls to the SQL database per minute, if it loops through the rows, etc., then you'll still pay the latency between the server and the database anyway. So there's only so much we can do. We can supply enough capacity, but we're still relying on sound algorithms and good code. Really recommend simulating your load using the performance toolkit, where you can basically set up the operation and you just crank up the usage and see how response time varies. Particularly for large installations, it's a very, very good habit, because now you're not just saying, I think this will work, you're actually proving it, because you can simulate it at 100 users typing in sales orders, you can simulate that. And then of course, what I always say, remember to enable telemetry, to find the bottlenecks now when you're in production, because as I said, we can supply capacity, we cannot change the code. All right, so we talked about the number of web service calls. And with that, with the work we've done on scaling, etc., we have been able to change the limits of how many web service calls we allow. There is an operational limits page where you can see what is officially supported. Now, the goals of changing the limits was, of course, to increase the amount of concurrent tasks of web services and the frequency of them as well. And then also to get some fairness into this, so that if you have more users, you get more throughput. In the end, there is no free lunch. The more you pay, the more you get. It's actually a relatively sound principle. But we also opted for simplicity. So it's not a perfect system yet, but it's an understandable limit. You don't need to do anything to set it up. You don't need to distribute it. So we decided to add to change it into being a per user limit. So let's take an example. Schedule tasks. So in the old model, we allow 3 concurrent running tasks per environment, regardless of how many users you have. So in the case on the bottom left, you had 6 users, each trying to run 5 tasks. Only 3 will get run concurrently, and will be run on one. Look how the MST acronym crept in again. In the new model, you can have 5 concurrently running tasks per user. So instead of having this limit per environment tenant, it is now per user. So in, for instance, the middle case, 3 users, each wanted to run 5. You notice also that they now get split over multiple VMs. So one of them is taking 8 of them, the other one is taking 7. So the more users you buy, the more concurrent tasks you can run. Except if you put them all on the same user. So this is the simplicity part of it. It is a simple system. We can elaborate on that later. But this was something that didn't require new administration pages, etc. So that's why we opted for that. And if we take an example of a cluster on 12th of February, if that was before we made the change, you can see the distributed bus. But the gist of this is effectively we changed the limits and suddenly we were running about 4 to 5 times as many concurrent tasks because this was a busy cluster. And the cluster held up quite nicely because it scaled back to the previous. So actually, our work to do autoscaling was a prerequisite for us being able to increase the limits. Now, there's also a concurrency limit for web service requests. The old one was you could submit 100 requests so that there were 100 being executed concurrently from your perspective. But what happened behind the scenes was 5 were running, 95 were queued, and we just beat off the queue. That's the same, except it's not the user. So even so you can say for a one-user system, we have the same in this case. Again, there's an example here of how they get spread over multiple VMs. Each user basically, there is a queue per user, 5 being run concurrently, 95 being queued up. The reason why we do this is particularly with web service calls. This is where we're very susceptible to just this burst of things coming in. And as you noticed before, it takes us a little while to increase the capacity. And we don't really want one person to ruin it for everyone else. So that's why they're queued up. But now it's per user rather than the environment. So we are distributing, spreading the workload across the different VMs, and you should in general be able to run more concurrently. Last thing